We will now discuss how energy and matter combine to form the atom, and how the energy and electrical fields of the atom then combine to form larger and larger objects. The current theory of the atom has a nucleus with most of the atom's mass comprised of neutron molecules and protons. This is surrounded by clouds of electrons in different shapes. The shape of these electron clouds is determined by finding the probability of finding an electron in any particular area. If the atom was surrounded by clouds of electrons, there would be a negative charge or repelling force between the atoms. The only way atoms would stick together is with chemical bonds. There would be no adhesion and no friction. There must be something wrong with this theory. When calculating the probability of finding electrons in any particular area, scientists made an assumption. They assumed that the atom did not exist in a magnetic field. This atom then doesn't exist on the Earth, doesn't exist in our solar system, doesn't exist in our galaxy, does not exist in the universe. If you start with an assumption you know is wrong, your model is not going to be correct. In the presence of a magnetic field, an electron will take a path perpendicular to the magnetic field. This diagram represents the forces of an atom within an electrical field. The forces of the matter are the electrical forces. You have the positive charge of the nucleus surrounded by a negative charge of the electron orbits. The forces of energy are the magnetic field, where you have a north and south perpendicular to the electrical forces. If this were the case, why don't atoms stick together in long strings with their north poles and south poles aligned along the axis? If this were to occur, you would also maximize the repelling forces of the electrical or matter fields. A more stable structure would be if the atoms were offset, creating lattices where the repelling forces were minimized. This diagram represents one such lattice, a cubic centric matrix, where you have an atom at the center of a cube and atoms at each of the 8 corners. The north pole of the center atom is attracted to the south pole of the 4 atoms in the upper level. The south pole is attracted to the north pole of the 4 atoms in the lower level. The repelling force between their electrical charges is minimized. These structures are a balance between the attractive forces of energy and the repelling forces of the matter. If the attractive force is greater than the repelling force, the lattice is a solid, where the atoms do not have much movement. If the repelling and attractive forces are equal, it is a liquid. If the repelling force of the matter is greater than the attracting force, you have a gas where the atoms are free to move. This type of structure makes an ideal medium for the transmission of light. If a disturbance was to occur to the center atom, the movement of the electrical field would repel the electrical fields in 4 of the neighboring atoms, transmitting the motion to them. At the same time, the movement of the magnetic poles would attract the poles of the other 4 neighboring atoms, transmitting the motion to them. Is there any evidence to support this lattice as a medium for the transmission of light? Yes, the dual thin slit experiment. If you shine a light towards 2 narrow slits close together, an interference pattern will appear behind them. There will be bright bands where light waves reinforce each other, and dark bands when they interfere with each other, canceling each other out. In the dual thin slit experiment, electrons were aimed at these slits. This also produced an interference pattern on the other side. When scientists tested to detect through which slit the electron passed, this interference pattern disappeared. This led them to conclude that the experiment knew they were watching and changed the results if they did. If light were traveling through a medium such as this, as an electron passed through this, it would disturb the electrical fields of the lattice. This would cause light waves to be generated, the speed of which would be determined by the tension in the lattice. The electron would be traveling at a different speed, so as it passed through the lattice, it would continue to generate light waves. These light waves the electron would produce the interference pattern seen through the experiment. When you detect the electron, you stop it or change its path. It would no longer generate light waves, and this would cause the interference pattern to cease. The speed of waves is determined by the tension in the medium in which they travel. To change the note of a guitar string, you add tension or loosen it to get to the right note. How fast you strike the string makes no difference. In Einstein's thought experiment, where he's talking about light coming from a moving train and on a platform, he was assuming that light was a particle, but the speed of the light is determined by the strength of the medium in which it travels. This would mean that as the magnetic field decreases, the layers will get further apart. This would cause the light to move slower as the distance increased. This would explain the redshift in light coming from far galaxies. It is not because the universe is expanding faster than the speed of light. It is because the light waves are traveling through weaker magnetic fields. A structure like this would also explain the photoelectric effect. The photon was proposed to explain the photoelectric effect. Scientists had decided that light was a wave, but in the photoelectric effect, when light strikes a certain crystal at a certain frequency, it emits a current immediately. It was thought that if light was a wave, it would have to take time to build up the energy to release an electron. In this structure, if a crystal had an electron field exposed, the oscillation of an electron in the medium next to it, if it was going at the correct frequency, could knock that electron free, causing an immediate electrical current. Solid materials are connected to the medium that transmits light, and this is how energy is transmitted to them by light. You can see that light travels faster in a denser magnetic field when you're swimming. When you look through the water, everything appears closer because the light is being transmitted faster in the water than it is in the air. When the sun, the earth, and the moon are in alignment, the moon appears 14% larger because the increased strength of their combined magnetic fields allows the light to travel faster. An image is produced when light waves travel without interfering with each other. When I see the marker here, the light waves coming from it do not interfere with it, producing an image. If I move my head back, the light waves coming from it produce another image that is different from the one I saw before. The light waves that produce that image have interfered with each other, destroying the image. We can see that light travels faster in a denser medium when we look at light traveling through a magnifying glass. In order for an image to be preserved, the light waves must travel in unison. They go to the lens and refract, travel through the lens, and come out the other side. In order for the image to be preserved, they must exit the lens in unison or at the same time. Since the distance this light wave travels is greater than the distance this light wave travels, the only way they could exit at the same time is if the light waves travel faster within the medium of the lens than in the air. The curvature of a lens is determined by how much faster the light is traveling within the medium. This type of crystal structure, where you have a balance between repelling forces and attractive forces, would also explain covalent bonds. The current theory on covalent bonds is that if two atoms have their outer electron orbits not filled, they can combine and share electrons, forming a chemical bond. With this structure, if the outer electron orbit of this atom had a few electrons in it, and this atom had gaps in it, one of the atoms could flip, causing the two electron orbits to mesh like gears and allow the north and south poles to become closer together and held together. In a covalent bond, it is the force of energy that holds them together. In an ionic chemical bond, it is the force of matter that holds them together. The resulting molecule would look something like this, where you have a north pole of one atom against the south pole of the other atom. There are two electron orbits meshing together like gears, and their south and north poles attracting to them. Is there any evidence that would support this theory of covalent bonds? In the current theory, helium is a completely inert element. Its electron orbit is full and should not combine with any other atoms. But helium occurs as a diatomic gas where two helium atoms combine to form a molecule. In this theory, helium would be the most reactive of all the elements. The two atoms could come closer together than any other elements. If this were the case, why doesn't helium combine with other elements? The size of the helium atom prevents it from combining with most materials. It can, however, combine with hydrogen, in which case you would get a molecule of helium dihydrogen. This molecule would be inert just like a helium molecule, and it would have the same molecular weight as a helium molecule. It would, however, have different field structures, which meant the repelling and attractive forces of it would be different than a helium molecule. There is evidence of this. When you cool helium down close to absolute zero, some of the molecules defy gravity and climb out of the vessel. This would indicate they have a different structure than other helium molecules. There is an experiment you can do to determine if helium and hydrogen combine. You take 2 atmospheres of radioactive hydrogen and combine it with 1 atmosphere of helium in a pressure chamber. You then ionize the gas, allowing a recombination. Because of the pressure difference, the 3 atmospheres of helium and hydrogen should convert to 2 atmospheres of helium dihydrogen. After the reaction, you strip out any remaining hydrogen and test to see if your helium is radioactive. If it is, you have helium dihydrogen. This structure of molecules would also explain friction and adhesion. The north poles of one molecule would be attracted to the south poles of other molecules. The amount of adhesion or friction would be determined by the number of atoms whose magnetic field. What evidence is there to support this theory that objects are held together by attractions of their magnetic fields? The superconductivity experiment supports this theory. In the experiment, ceramic discs made from exotic metals are cooled close to absolute zero. They are then placed over a magnet and electrons are added. This causes the discs to float above the magnet. The current interpretation of this experiment is that when you cool the discs down close to absolute zero, you destroy all electrical resistance. When you add the electrons, they then form a current that produces a magnetic field that is repelled by the base magnet, causing the disc to float. The problem with this interpretation is that when you add electrons, they do not form currents. They disperse and form a charge. If they did flow in a current, in the presence of a magnetic field, they would produce a magnet that would be attracted to the base magnet instead of repelled by it. In this theory, when you cool the disc down close to absolute zero, you take away energy and weaken the attractive force between the magnetic poles. When you place it over a magnet, you cut in half the number of attractive sites. When you then add the electrons, they increase the electrical charge, increasing the repelling charge, causing it to float above the magnet. It is the weakening of the attractive force and the increasing of the repelling force that causes the disc to float. Fields are paired. By having atoms consisted of 2 forces, one of matter, electrical, and one of energy, magnetic, we can build lattices that transmit light and produce molecules that can stick together without chemical bonds. In the final episode, we will discuss how energy and matter combine and why things are radioactive.